this integral convergent. This integral is convergent, means it has a value. Therefore, this means what? Means that the series is convergent. So the final answer to this, okay, this will be 15. So because of this, so from integral test, right? Therefore, this series is convergent. All right, let's maybe look at some more. We still have some more time, so same group. I'm looking at how about 23? Is summation k from 0 to infinity. 1 over square root of k plus 8. All right, now they give us the hint. Use the integral test. Very simple, right? I'm going to let f of x. This is ak. So f of x will be a. You just change k to x. So now the question right now is this series, is this integral convergent? That's really the question. All right, so let's see. So, okay, what does this have to integrate this? So this is because improper integral, so I have to make to a. And this, we know that we use substitution, right, into this. So this will be equal to 1 over square root of u, right? And d is dx. Now I don't have to change the bound as long as I make a note here, namely those bounds are for x, not for u. Because later on, when I want to substitute those numbers into it, I have to change u back in terms of x. But it's so easy because I already know what the relation between u and the x. Okay? So this is equal to what? The integration is really what's matter. And this is u to the minus 1/2, right? 1 over square root of u is u to the minus 1/2. So when you do the integration, what is this? 1 over minus 1/2 plus 1, right? And u to the minus 1/2 plus 1. Okay, and this is x. X equal to 1, x equal to b. So this is equal to limit b equal to infinity. Negative 1/2 plus 1 is 1/2. 1 divided by 1/2 is 2. And u, okay, well, I want to substitute this into here, so let me change u back to x. It's x plus 8. Minus 1/2 plus 1 is 1/2. And this is x equal to 1. X, so this 1. I don't need to write x anymore because there's already x. And that's b. Okay, so sometimes it's difficult to see. Okay. So this equal to what? Limit b equal to infinity 2. B plus 8 to the 1/2 minus 0.19, so 2 times 9 to the 1/2. Well, what is this? When b go to infinity, b plus a goes to infinity. B plus a to 1/2, this also go to infinity. This whole thing go to infinity when b goes to infinity. So this is infinity. So this means what? Divergent. Divergent. Convergent means integral is a number. If other than that, if the integral is infinity, it's divergent. Therefore, our conclusion, so from here, use the integral test because they told us to use integral test. So this summation is equal to what? Equal to yeah. So this k from 0 to infinity, 1 over square k plus a is divergent. Okay, it is divergent. All right. Any question about this? Those two sections. I mean, the section where, I mean, in chapter 8 especially, we are talking about convergence, divergence, all this what we are doing here. Okay. So let me take a look at the next group of problem. Okay.
I have a question. When you're doing this, you change the bound from 0 to 1.
Oh, well, good question. Okay, good question. Let me see. Okay, you're right. Okay, let me change this to 0. 0 to 0. Okay, 0. Thank you. All right, you're right. So it's 0, and this is 0. And this is 0. This is 0. 0 plus 8 is 8. So this is now 9. So this is 8. Okay. But this still go to infinity, so it's infinity. So that way. But okay, this match with this. So 0 to infinity and 0 to infinity. I mean, yeah, k start with 0, this is 0. Okay. All right. Okay, so this is 14. So many, 15. And this is 16, right? Any more question? Any additional question? All right, now we want to do the last group of the problem here. Last group, again, they give us hint. And then you have hint. Last group is 29 to 34. It says they give us use the P series. Right? Now what is P series? Let me take out our thing, right? P series is, now actually I remember what it is. I just want to, here. Summation of series 1 over k to the p. This is called P series because I have a p here. Is convergent if and only if p is positive when p is greater than 1. Okay? So this section is very easy. This group of one, because this is a P series. Okay, so let's see what the question is, all right? How about let's look at 29. I hope I just look at it, I know you immediately k from 1 to infinity, 1 over k to the 10, right? Aha. So is it convergent or divergent? Like this one, right? P series, this is P series. P is 10. 10 is bigger than 1, right? So the convolution is what? Convergent. By P series. Okay? Now this is so easy, so I can do all these 3 problems in less than 1 minute. Okay? So I look at this k from 3 to infinity, 1 over k minus 2 to 4, right? 3 k minus 2 to 4, yeah, that's right. Okay, so is this convergent? Aha. Well, in other words, can we actually add them up? Okay, now this is very simple. Okay, looks terrible, it's very simple. I'm going to look at, so this is, let's think about it. K equals 3, let's start 1. 3, when k is 3, 3 minus 1, right? So, and let me just write it out. Write it out, you see what's going on. I mean, it looks horrible, but actually it's very simple if I write it out. When k equals 3, 3 minus 2 is 1, right? Okay, 1 to 4 is here. When k equals to 4, 4 minus 2 is 2, right? When k is 5, 5 minus 2 is 3. Aha, so it's actually, this is really k to the 4, k from 1 to infinity. Because once I write it out, I see this guy is this guy. P series, 1 over kp. This is converted p greater than 1. P series with p equal to 4 greater than 1. Answer is what? Convergent. I mean, if I look at this, if I have to take fourth power of this, k to the 4 minus, plus or by a lot of things like it. But if I actually just sit down and carefully write it out, it's so simple. This guy is this guy in disguise. This is the same thing. And I know this is convergent because case P series, P is 4, so it's bigger than 1. All right, let's do one more. So, number 33. So this actually is the last problem in this section. And then I still have something. Okay, but so this is 1 over. This looks like 1 minute question. K from 1 to infinity. Well, okay, so let's just write it out. This is 1 over k to the 1/3, right? So this is the P series, where P is 1/3. 1/3 is what? Less than 1, right? So what? 1 over k to the p is convergent if and only p is bigger than 1. Less than 1, divergent. Okay. Okay, so I guess that's all for today. For Thursday, we still have 2 more sections to go. Okay.